5 molar per second was the average rate of disappearance of Ne2O4. Okay, so now we need to use the stoichiometry of the equation here. Okay, so from the equation here, we can write the rate. Okay, so rate is equal to, as you can see here, so rate is equal to, so in this case it will be negative delta Ne2O4 delta T, okay, which is equal to 1 over 2 NO 1 over 2 delta NO delta T. Okay, there's also oxygen there if you are though it's not needed. So oxygen delta oxygen over delta T. Okay, but our focus, since we are looking at we have NO, this is the concentration of NO, then we want to calculate the concentration of Ne2O4. Okay, so our concern is only about these two, so we don't have to worry about oxygen. Okay, so in this case now we want to calculate what is the average rate of disappearance. Okay, so we write the equation, which is this one. Then now it will be equal to we want to calculate the rate of this, okay, the average rate of disappearance of Ne2. So now there's a negative sign there in front, then here we have a positive value. So now we are going to write negative delta Ne2O4 then over delta T, so which is equal to now, so our delta T, we know is the time is in seconds. Okay, it's in seconds, so we can simply write S here, S, since we know time is in seconds. Then half concentration of NO here, concentration of NO is given, which is 4.6. okay, so 4.6 times 10 to the power negative 5, 4.6 times 10 to the power negative 5 molar, okay, molar, then over delta T, S.
Sir.
Yes, sir.
Oh, sorry. In the question, the one which you wrote as the concentration, is it not the rate given in the question?
If the average rate, yeah, it's the rate molar per, it's the rate time, not concentration. Okay, so even when you write it like this, molar over second, since rate, you can see the units here. The rate is what? Here we are dealing with rate, not concentration. It's rate over time, rate over time. So the concentration is in molar, then the time is in seconds. So if I write it like this, M over S, it means it's just the same as M slash S. Okay, so here we want to find this one now, delta delta N2 O4 delta T, which is the rate. Okay, so now if we have the figures like this, then what will happen here? Since we have a half, so we find half of that. So help me to calculate, since we changed the equation. What is half
2.3
of it?
times 10 to the power 5 negative 5.
So 2.3 times 10 to the power negative 5
Yeah.
molar seconds. So here, now this side there's a negative. As you can see, there's a negative. So meaning that now this one will be delta N2 O4 delta T, which is the rate, is equal to negative that. But it is customary to write rate. Rate is always a positive quantity. Okay, so now we are going to write this rate as delta N2 O4 delta T is equal to 2.3 times 10 to the power negative 5 molar second as a positive quantity. We know it is negative, but we normally represent rate as a positive quantity. Okay, so rate is always positive. Rate is always positive. Okay, so that is how we can calculate. Yes, what's the question?
So, in case you find the final answer is positive, if the problem was okay, find the positive answer.
Okay. What's the question again?
Is it okay to find the positive answer? Like, find the final answer is positive.
So we are saying rate is always positive. So what we are saying is, even if you find a negative rate, change it to report it as a positive rate. Always report rate as a positive quantity. Even if it is negative, change it to a positive.
Okay. What is to ask is it possible
That's
to
how
find
it
a
is.
positive answer, like direct positive, like when we are calculating there, to find it
when we
positive?
are calculating rate, but listen, it's like this. We are looking at the rates of what? Reactants. Not in this case here, or in our calculations most, we shall always deal with reactants. Okay, so the rate of products will not be considered, because the reverse reaction does not contribute to the overall rate, so it's negligible. So we shall always deal with the rates of reactants. So we shall not ask you to say calculate the rate of the product. So that is why we say rate is equal to negative reactant over delta T, so that this negative will cancel that negative to give a positive rate. But we know that the rate of the reactants is always negative. Doing what? They are decreasing. Products are increasing. Okay, so let's have another example. about okay, so you can have this example. Let's write this chemical equation. So we are dealing with rates of reactants, not products. So we shall always find the negative quantity, then change it to become a positive quantity. Okay. So suppose we have the equation C4H9Cl. It's an aqueous solution. Then plus water, then forms the C4H9OH. OH, then plus HCl. Okay. So this is the equation. So we can now relate. You can see here in this equation that the rate of this, the rate of this to the rate of that, the more ratio there is 1 to 1. Okay. So to write the rate, we can say rate is equal to negative this C4H9Cl, okay, over delta T, which is equal to now positive delta C4H9OH over delta T. Okay, so you can see here, because here the more ratio is 1 to 1. Okay, so if the more ratio is not equal to 1 to 1, then we use that equation that I had given you earlier of 1 over A, negative 1 over A, negative 1 over B. You consider the coefficients. Okay, so now let's look at rate laws. Okay, let's look at rate laws. So suppose you are given I think before we go to rate laws, we need to let's look at concentration and rate. Concentration and rate. Concentration and rate. Okay. So one thing you need to know is each reaction has its own equation. And that gives a rate as a function of reactant concentration. So rate as a function, of reactant concentration. Rate as a function of reactant concentration. Rate as a function of reactant concentration is what we call rate law. Okay, rate law. Rate as a function of reactant concentration is called rate law. Okay, so to determine the rate law, we measure the rate at different starting concentrations. So for example, we can have the reaction. Let's look at this reaction. NH4 plus NO2 plus NO2, then gives us N2 gas, then plus water. Okay, so this is a reaction. This is a reaction. So we can write the rate law of this reaction. So now to write the rate law of this reaction, we are going to look at the reactants. So you don't worry about the products. The products will not appear in the rate law. We are only looking at the reactants. Okay, since the reverse reaction is not considered, it's negligible. Okay, so now to write the rate law for this, we are going to say rate is equal to K. You can see we have introduced the K, concentration of NH4 plus, concentration of NH4 plus, and that to the power N, times the concentration of NO2 minus to the power N, Okay, so such a reaction is what we call rate law. It is called rate law. Okay, so this is the rate law. So rate is equal to K times concentration of NH4 plus times concentration of NO2 minus. So the K is the rate constant. K is the rate constant. Determined by experiment. K is the rate constant which is determined by the experiment. Then you can see the exponents. We have the exponents N and M. The exponents N and M are orders of the reactants. Orders of the reactants. So N and M are orders of the reactants. Okay, orders of the reactants or concentration or reaction with respect to each reactant. So these are orders of the reactants or orders of the reaction with respect to each reactant. Then N and M are also determined by experiment and not from the coefficients of the balanced equation. Okay, so these are not coefficients from the balanced equation. So these are determined by experiment. And not from the balanced equation. Okay, then K is unique. K is unique for each reaction. K changes with temperature. Okay. So now, how can we determine K? How can we determine the rate law? How can we determine the rate law? Okay, so to determine the rate law, we use a method called method of initial rate. So we are going to use the method experiment 3, 0.200. Okay, these are the values. So we go to any, let's determine the rate law. So first of all, you are dealing with two reactants. If it is one, it is just N. If there are two, then it is N plus M. So what we are saying is this. So suppose you have a reaction. A forms the products. A forms the products. Okay. So in this case now, rate will equal to K to the power N, since it is only one. Okay. Then now, if you have a situation like this, A plus B forms the products. So in this case now, rate will be K, A to the power N, then B to the power N, since there are two. So which is the case here? Okay, so now let's write. So in this case now, we know that there are two reactants. So we have N and M. Okay, so solution. So rate in this case will be, it's A now. We want to determine the rate law. So now it will be A. It's even time up, huh? Are you having
Yes, sir.
Yes, sir. The bundles.
Yes, sir.
Yes, sir. The bundles Yashira.
How are you?
Right.
Let me just see. Let's just determine the rate law. Then we shall continue when we meet next week. Okay.
Yes, sir.
Let me just determine the rate law. So in this case, we are going to say rate is equal to K times the concentration of NH4. Concentration of NH4 to the power N times the concentration of NH2, NO2 minus to the power M. So this is the rate. Okay. So now you are going to analyze the experiments. We have 3 experiments. We have 3 experiments. 1, 2, 3. So you can see here. First of all, we want to determine. We can either start with determining the value of N or M. So first of all, identify 2 reactions or 2 experiments where the concentration of someone to mute the mic. Okay. So you can see here the compare experiments 1 and 2. Compare experiments 1 and 2. So you can see here that the concentration of NH4 is constant, 0.100, while the concentration of NO2 minus is changing, 0.005, 0.0. So we can use these two to calculate the value of M. Okay, so we are going to apply the same equation here that we have written. Okay, so we are now going to say rate.
Why did you shift?
Rate in this case, rate, which is equal to, so rate is given here. Okay, rate is given. So we have rate 2 over rate 1. Okay, so we are going to look at rate 2 over rate rate 1. Always start with a bigger number. Even if you start with this one, it's the same, but it will give you fractions which you need to do my indices. So it always becomes easy to use a bigger number on top here. Or this one, a bigger number, then a smaller number for easy to divide. Okay. So now R2 rate 2 over rate 1. Okay. So now we are going to say rate 2 over rate 1, which is equal to K. Then our concentration of NH2. We are looking at rate 2. So rate 2 is this one here. This line, rate 2, experiment 2. Okay. So concentration of NH4 is 0.1. So you write here 0.100 molar to the power n.
I'm in class.
Then times the concentration of NO2.
But I'm failing to.
For rate 2,
I'm
which
failing
is
to
this one.
concentrate.
0.010 molar to the power
I'm actually failing
n.
to concentrate. That's the reason I called you.
So now, since here we need also to calculate, since the rate
I can't
is
concentrate,
given, we
class.
need to
So
indicate it here. So
actually,
we write,
no
since we are looking
cutting
at
and
rate
choking class.
2
I'm just wasting my
over
bandwidth.
rate 1, which is equal to, so rate 2 is this one here, 2.7.
You're also having
2.7 times 10 to the power negative 7. Okay. Then over.
These classes are bad. No?
We go now to rate 1. Okay. Rate 1 is this one, 1.35 times 10 to the power negative 3. So you write here rate 1, 1.35
you have got
times 10 to the power
exam.
negative 7, which is equal to over.
You're opening. Your friends are coming.
Okay. So
like
K,
one of my friends said,
then
coming from
we go now to concentration of NH4. So concentration of NH4 for rate 1 is this one, 0.100 molar to the power n. Then we write concentration of NH2 for 1, which is 0.0050 molar to the power n. Okay. So now, when you look at this equation here, clearly you can see, have you seen here, that this one is the same. So the n will cancel. So you cancel this one, you cancel this one. Everything will cancel. Okay? You cancel there 0.1. You can see 0.1, 0.1 kk. This will cancel. So n will go. Then now, we need to divide here. So 2.7 times 10 to the power negative 7 over this, you are going to get a 2. So 2, which is equal to now, here you divide 0.01 over 0.05. You are going to get a 2. So this one now will be 2 to the power m. 2 to the power m. So 2 is equal to 2 to the power m. What is the value of m in this case? The value of m is equal to 1. So we have determined the value of m. Okay, that is how we do it. Then now, we need to now determine the value of n. So we use again 2 reactions which will give us the m constant, where m is a constant and the n is changing. Okay, so we have determined, so we can write it here. The value of m is equal to 1. So let's see now.
You want him to see me?
Which experiments are we going to use where n is a constant? N is a constant. I mean, m is a constant and the n is changing. So from these values, you can see clearly here that experiment.
Is it not the one I was talking to?
Experiment 2 and 3. You can see here, these two are constant. Then m is changing. So we are going to use the R3 over R3 over R2. Okay. So that's what we are going to use for the rate.
That's what I forgot. Those things are for my man.
So we are going to use this one is bigger. Let's use a bigger one. So it is R3 over R2. So R3 over
you're going to church.
R2. That is the rate. So rate R3. Rate R3 is 5.4. 5.4
Where?
times 10 to the power negative 7, which is equal to K. Concentration of NH4. It is 0.200 molar to the power N. Concentration of NO2 0.010 molar to the power N. Then over. Let me just finish to ask questions later. Then R2 initial rate for R2 2.7.
No, on Sunday I'm also
2.7 times 10 to the power negative 7 over
I'm going
K,
to Kamulanga.
concentration of NH4 for 0.1.
You know where it is, huh?
0.100 molar to the power N. Then concentration of
I'm going there for the meeting.
NO2, it's this one, 0.010 to the power M. So you can see now, you can see that that M will cancel, M will go, okay? 0.01. So M is going to cancel. So you cancel. Of course, K will also cancel. Okay? Then you divide. We assume the units are here. They have cancelled. Okay? Then now 5.4 over 2.7. You are also going to get a 2. It's a 2. Then 0.2 over 0.1 is equal to 2. So it will be 2 to the power N. Clearly, N is equal to 1. Okay, so both N and M are equal to 1. Okay, so it is just by coincidence that when you compare now, the coefficients here, it is 1. Here it is also
maybe they'll
1.
be coming next
So
week.
it's not always that the coefficient will be equal to N and M. It is just by coincidence. You need to calculate. Okay, so N and M are equal to 1. Then now, what is the rate law? So in this case, the rate law will be rate is equal to K times the concentration of this to the power N. So N is equal to 1, M is equal to 1. So you substitute there. Okay. So rate now. So you write rate law will equal to K.
Maybe I don't know.
Concentration of NH4 times the concentration of N2 minus. So this is the rate law. Okay, N is equal to 1, M is also equal to 1. Then the next question was what? What is the overall order? So overall order you add. So this is our answer for A. For B now, overall order you add N plus M, which is equal to 1 plus 1, which is equal to 2. So the reaction is second order overall. Then the third question is what? Calculate the value of what?
Okay, do you know where
K.
Roma SDHS is?
Calculate the value of K. Okay, so to calculate the value of K, you are going to pick any of the 3 experiments.
You said they.
Do you know where Roma constituency is?
To calculate the value of K, you can pick any of the 3 experiments. Okay? So now.
So you are moving fast and we are not hearing anything.
Hey,
have you seen how we have calculated the rate law?
Yes.
Yes, sir. And sir, you said you just calculate the rate law and then
No,
now you're proceeding to.
I'll be
Yes,
moving
the
on
time is up
campus,
and bundles
Pajang.
they are finishing.
Okay, so we can end here, then we'll continue from now again. To
When
continue from
you
here,
come,
we'll need
guys,
again
Baba
to start
Machana will come.
writing these things. We should be not forget.
Do you have a room, you?
Just finish.
I don't
Just
have a room.
finish.
So let's finish.
Finish, we go.
Let's just finish.
Because we are not going to
But
write these
I'm going to
things
that
again.
Semuchan room.
Okay, so now rate is equal to 8.
I heard that you could be
Then the overall order is
Wala,
1 plus
wala.
1, which is equal to 2. Then to calculate the K, I said use any of the 3 experiments. Use any of the 3 experiments. So you can use the values for
Wada.
experiment 1, 2, or 3. Okay, so for the sake of just
Wala.
using, okay, let's pick 1. Okay, so if you pick 1, it means the
They can't
concentration
manage.
of NH4 is equal to this. Concentration of that
What did you see to
NO2 minus is that. Then the rate is equal to that. Then
Bad
substitute
manner.
in the equation now.
Bad manner.
Calculate K. Okay, so we have picked 1, and whichever experiment you pick, K will be the same. It's a constant. So now, if you pick 1,
Guys,
we
you are
have picked
crazy.
experiment 1. So we are using this rate. Since the rate
You are
is
hiding,
K,
you are hiding your place.
NH4, then
You are hiding. You don't
NO2
want me to know where you stay.
Okay, so we are picking experiment 1.
You know what?
So you can pick whichever experiment you want. So for experiment 1, we start with rate. Rate is what? 1.3. 1.35. So you write 1.35 and 10 the power negative 7 molar second. You include the units. Then K. Then concentration of NH4 for 1.
So you think
it is
I can keep
0.1
on coming when I'm a student?
molar.
I have a lot of things to
Then
be doing.
NO2 0.005 0.0050 molar. Okay, so you calculate now what will be the value of K. So you multiply that number. You can see here clearly that you multiply this and divide
You should come and see you tomorrow.
into that. Okay, so when you do your
Come and see you tomorrow.
your calculations, you find that K.
I said come and see you tomorrow. Friday, I can't come there instead. You don't
K will give us 2.7. So K is equal to 2.7.
Yes, you
times
can.
10 the power negative 4. 2.7 times 10 the power negative 4. Okay, so now if we use molar, what will be the units? So we are dividing now. We are here M times M, we have M squared. Then we are dividing into that. So we have molar. You can see here it is molar second. Then divide by M squared. Okay. So which is molar over second times 1 over M squared. So this M and that M will do what? Will go.
Happy birthday.
So we are going to have 1 over SM. Okay, 1 over SM. So this one is the same as 1 over molar second. So 1 over molar second. How are we going to write it? 1 over molar second. So it's just the same as molar.
Okay.
Molar. This one. Okay. Per molar per second. Per molar per second. Or you can put both, then it to the power negative 1. Or this one can also be written as
if you manage to come
MS is the same, like that. But we normally use that one.
If you manage to come on Sunday to
molar,
okay.
Then so those are the units for K. Then the other question was calculate the initial concentration
like Sunday, Monday,
when the concentration of this was given and the concentration of that was given. Then, what are you going to do? Since
Okay,
you know
okay, come
K,
now, I
you
send you
put
money.
K, you put K here. K is known, you have calculated
Come, I
the
send you
K.
transport money.
So
Now.
you can calculate the rate. You put that concentration is 0.5 here, 0.8. Then you calculate since K is known. Hope it's clear now. You can use the method of initial rate to determine N and M. Okay.
But
Any question?
yes, sir. Does the constant have the units?
Yes, we have put the units here. Can't you see the units here? The units are what? Molar per second. That's what we found.
It's a lie.
Yes, the units are there, depending which units you are using. So the units will be different depending with the type of reaction that you are looking at. Okay, so suppose we are D squared here. The units would have changed. They wouldn't be like this. So K will have a different unit. Okay, so we can end here. What I'm going to do on the weekend, I'll make some videos, then I'll send it to you so that you can watch and understand this. All right, we can call it a day.
Sure, thank you, Mister.
You're waiting for me to do it.
Questions?
It's a school bag. I'm not a student. I'm not a what is it? Me, I don't go in school bag because I don't go to school. That bag is just for you. Me, I don't go to your school.